Okay, so for questions 1 through 9, you have to write the name of the parent function, as well as the equation, which I'll get to in just a second. But if we look at this first one, remember anything that looks like a V is an absolute value. This is linear, it's a line. And a quadratic is always something that does a U, is a parabola. So make sure that you know that for your test. Okay, now they also want you to write the equation. So the equation for the absolute value will be f of x equals, and simply the absolute value of x. Number 2, linear, f of x equals, and that is the line y equals x because it goes through the origin and has a slope of 1. And the last one for on this slide anyway is f of x equals. A quadratic is always an x term that will be squared. 4, that is a square root. It starts at 0, 0, and it kind of does a little rise here, slows down a little bit here, but continues to rise just at a shallower rate. So that's a square root. A cubic, remember our point of inflection, that's kind of our center point here. We have a concave up to the right of it, and a concave down to the left of it. Cube root, well, if you look at that, that's just this cubic flipped on its side. Okay, so we've got concave up here, concave down here. Now we have to write the equations of these. So, oops, let me put my pen on there. This is going to be f of x equals radical x. This is f of x equals x cubed. And number 6 is f of x equals the cube root of x. All right, the last 3 here. So this looks like an E graph, which we call an exponential. Now just be careful. I know that this might not be the best picture in the world, but remember we have an asymptote here. So my exponential does not hit the x-axis. Same thing here with, this looks like an ln. We do not hit the y-axis here. That's an asymptote. Okay, and an ln, remember we call a natural log. Okay, and the last one, this is the 2-part. And the 2-part is called a hyperbola. Same deal. Asymptote, asymptote. Same up here on this side. Asymptote, asymptote. All right, now we need to write the equations of these. So the exponential here, we're just going to write f of x equals e to the x. Number 8 is f of x equals the ln of x. And the last one is f of x equals 1 over x. All right, now let's look at number 10. Number 10 is giving you the parent function, and it wants you to perform a couple of transformations. So we've got a horizontal shift, a vertical shift, and a reflection about the x-axis. Well, I know when I reflect about the x-axis, I'm going to have a negative in front. So let's look at the square root now. Horizontal shifts always get put underneath the square root and in the opposite sign of the direction they're referring to. So in this case, I would say x minus 8, and most people would think it would be x plus 8 because it's to the right, but we kind of do the opposite sign there. And a vertical shift down, and the vertical always goes outside, and in the direction that we're referring to here, we are referring to down, so we just use that exact sign. Okay, down would mean negative, that means negative. Horizontal shift, right means go to the right. We would think positive, but we actually do the opposite. All right, number 11 is f of x equals x cubed. So I have a vertical narrowing. I'm looking at this last one here because that's the number that will go in front. So I'm going to have 3. Then I have a horizontal shift to the left 2, so that will actually be plus 2. And then we're going to cube that. And any vertical shift, remember, always goes outside the parentheses. All right, number 12. This one says a vertical narrowing or stretch by a factor of 4. So 4 is going to go out on the outside this time. Horizontal shift, it's left 3. So I'm actually going to write plus 3. And remember, vertical shifts go outside the parentheses. Down 7, so I write minus 7. Number 13, we've got a cube root now. Now we have a reflection about the x-axis. So that means let's negate our equation. And let's see, we've got a cube root here, right? So let's put that in there. Horizontal shift goes inside. It says to the right 1 unit, so I'm actually going to write minus 1. Vertical shift goes outside. And there we go. All right, number 14, we just have to write the equation. Now, if you notice the equation, or the picture, I should say, this is a cube root. And normally the cube root's point of inflection here is usually up here at 0, 0. So we shifted down 2 units. So if we want to write that equation, we just write f of x equals, and it's a cube root, and we have a shift down, so that is a vertical shift that always goes on the outside. Okay, 15. 15, we have a square root, and the square root's starting point is usually here at 0, 0, and then it goes like that, right? So we went from here all the way to the left 4 units. So that equation is f of x equals, and we have a horizontal shift, so that is going to be underneath. Okay, so then 4 units to the left would be underneath, and to the left would actually be plus 4. All right, let's look at 16, last one on this page. So that's an absolute value. And if you look at this one, absolute value, normally that turning point is right here at 0, 0. It moved to the left 1 and up 2. So let's write the equation. So we got f of x equals, now remember when we move left or right, that goes inside. And we move to the left, so that's actually going to be a plus 1. And then we moved up 2. So we're going to write plus 2. All right, so 17a says state what the parent function is. So it's a quadratic because we have an x squared. State the transformation that's used. Well, I probably would take this, just you can look at this a different way, maybe this will help a little bit, is I can make that negative and then x plus 7, that quantity squared. And that is, if we look at this, this is a positive 2 right here, so I'm going to swing that positive 2 at the end over here because that's where we're used to seeing it. So maybe you would prefer that. Okay, so then if I look here, I see that I have a reflection in the x-axis. I have a horizontal shift to the left 7, and then I have a vertical shift up 2. So then just like that, reflection in the x-axis because of that negative, horizontal shift left 7 units because of the positive 7 being inside the parentheses, vertical shift up 2 because the number on the outside is a positive 2. All right, let's look at number 18. So if I look at that, I can see that that is a square root. I see that I have a horizontal shift, and I have a horizontal shift to the left 3, and then I have a vertical shift up 1. So there we go. Horizontal shift left 3 units, vertical shift up 1. Okay, and I know we have to graph these. I'm going to save that to the end. So if we look at number 19, I see that I have a an absolute value here, right? So that would be an absolute value function. So let's write, I'm going to abbreviate absolute value. And I see that I have a reflection in the x-axis, horizontal shift to the right 1, and a vertical shift up 4. All right, so there we go right there. So reflection in the x-axis, horizontal shift right 1 unit, vertical shift up 4 units. Okay, so let's go back to 17 and let's get ourselves a graph. Now, an x squared, remember, would just be a parabola with its turning point at 0, 0 and pointing upward. So I like to use, remember, the 149 method. So hold on a second. Let me get rid of that. Okay, so here we go. So 1, 4, 9 plus or minus 1, 2, 3. Okay, so I'm going to start with the turning point. So let's see what I have here. So I know that I have a horizontal shift to the left 7 and then up 2. So just to show you, I'm going to go 1, 2, 3, 4, 5, 6, 7. Then I'm going to go up 2. And that's where my turning point is going to be. Okay? All right, so let me get that. So that would be, now this graph is very, very tiny, so I'm sorry if my points are a little off, but that's where that should be. Okay, now this parabola is pointing downward because we have a reflection in the x-axis here. So instead of going up 1, 4, and 9, we're actually going to go down. So down 1, 4, and 9. So I'm going to go down 1, and then I'm going to go to the left and to the right 1. Then I'm going to go back to the turning point. So I go back here, and then I count down 4. 1, 2, 3, 4, left 2, right 2. Okay, so 1, 2, 3, 4, left 2, right 2. There we go. Now we really only need minimum of 3 points on any graph. I've got 5, and because this graph is so tiny, I'm quitting while I'm ahead here. And there is my picture. And this is the graph of g of x. All right, so let's go to the next one. The next one is a square root. So I want the square root, and I have a horizontal shift to the left 3 and then up 1. So 1, 2, 3, up 1 would put my starting point for that square root right there. Okay, now what we can actually do is go sideways on that 1, 4, 9, right? So what I'm going to do is I'm going to go to the right 1 and then up 1. And that's going to be the first point. All right, then the next one, let me get my little pointer going here. So the next one, I'm going to go sideways 4. 1, 2, 3, 4, and then I'm going to go up 2. So that's the point that I want to plot, which is 1, 3. Okay, so that's going to be right there-ish. I'm so sorry. And then I'm going to, I have 3 points there, and there is my graph of h of x. All right, then let's look at number 19. That's an absolute value, but now let's just be careful with this one. The absolute value is flipped. And my turning point is going to be shifted to the right 1 and then up 4. Okay, so that means that my point on my absolute value is going to be right there at 1, 4. And then remember that the slope of each part of your absolute value is going to be +1 and -1. And also remember that we're reflecting in the x-axis. So this absolute value is actually going to be pointing down. Now, I'll do the best I can here. So this part of the absolute value has a slope of -1. And then if I go in the other direction, this part of the absolute value, will have a slope of positive 1. And there's your graph of m of x. Okay, so then the last page, 20, 21, 22, we've got a quadratic, and a cubic respectively. I think that that's pretty straightforward. Now, because of the 2 here in front of the x squared in number 20, we know that we are actually going to narrow out our parabola, and it's going to narrow by a factor of 2. Whereas in number 21, we're actually going to be widening by a factor of 1/2. So remember, if the number is a whole number greater than 1, or I should say a number greater than 1, we're actually narrowing by whatever that number is, so by a factor of, in this case, 2. And if the number is between 0 and 1, which would be a fraction, we're actually widening by a factor of 1/2. All right, and then let's look at number 22, and then I'll do the graphs. We have got a horizontal shift, and we have a horizontal shift to the left 1, and then a vertical shift down 4. All right, now going to the graphs, look at number 20. It's a quadratic, so I'm going to use the 1, 4, 9, plus or minus the 1, 2, 3. Now here, though, we see that we have a factor of 2, which means these numbers are going to get multiplied by 2. So then this 1, if I multiply it by 2, is going to become a 2. This 4, if I multiply by 2, is going to become an 8. And that 9, if I multiply by 2, is going to become 18. So we don't have any horizontal or vertical shifts, so I know that this parabola is going to be right there, starting right there. That's my turning point. But normally what I would do is I would go up 1, and then I would plot a point to the left and to the right 1, right? But instead, because we have a factor of 2 that this is getting multiplied by, we're actually going to go up 2 and then plot a point left 1, right 1. Then we'll go up 8, then go plus and minus 2, okay? All right, so I'm going to go up here. Let me use my pointer so that you can see. I'm going to go up 2 instead, so up 2, left 1, plot a point, right 1, plot a point. So at -1, 2, and at +1, 2. So just like that. Now the next one, I'm going to go up 8. So I'm going to start here, and I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go to the left 2, plot a point, and to the right 2, and plot a point. All right, now I don't have 18 spaces, so I'm not counting up 18 from 0, 0, but I've got 5 points here. So I can just go right ahead and I can connect these guys and see how narrow that looks. And this would be the graph of n of x. All right, so similarly, I'm going to do the same thing with number 21, but now I'm widening by a factor of 1/2, in which case my 1, 4, and 9 are going to get multiplied by 1/2 or divided by 2. So 1, if I divide that by 2, is 1/2. 4, if I divide it by 2, is going to be 2. And 9, if I divide it by 2, is going to be 9/2, which is 4.5. Again, I don't have any vertical or horizontal shifts, so I'm just going to go right ahead and put my turning point right there at 0, 0. And instead of going up 1 plus or minus 1, I'm going up 1/2 plus or minus 1. So I'm going to go right up in between 0 and 1 right here. Left 1, put a dot, right 1, put a dot. Okay, well, I apologize because this one is off, but I cannot, it's so tiny, I cannot get it to be right down there. But that should be at 1, 1/2. All right, now I'm going to go up 2, a little bit easier for me to do with my stylus. So I'm going to go up 1, 2, then I'm going to go to the left 2, put a dot, right 2, put a dot. All right, I've got 5 points, and really that took so long. So I am just going to plot those, and that's what my n of x looks like. Okay, I just want you to compare. Look at how much wider this graph is compared to this graph right here. This is half as wide. This is double as wide. So you can see, even though this number is a 2, it actually squeezed this in, this parabola. And even though this is a 1/2, it actually opened it up. Okay, the last question. So we've got a cubic, and a cubic, its point of inflection is usually at 0, 0, but I've shifted to the left 1, and then down 1, 2, 3, 4. So you should be putting a point right here at -1, -4. And then remember, the other 2 points, you're going to have one diagonally up to the right and one diagonally down to the left, just like that. So I'm going to plot those. And then remember, from that point of inflection going up to that other point that I plotted to the top right corner, you're going to do a concave up, and then we're going to do a concave down here. Okay, and there is your picture of n of x. I'm sorry if it looks a little wavy right in here. It's not supposed to. So from here it just goes whoop up and then whoop down. Okay?